Okay, so let's try to look at it with a more intuitive example. For example, if this is your some kind of activation map, if you try to visualize this, we have like activity in this region, right? And this shape looks something like this. Okay. Now, if this is your input image, the triangle shape, and let's say we are interested in this location. Okay, so it will look something like this, and this is the input image. And if our kernel is something like this, which I showed you earlier, you can see like this actually is matching perfectly with this kind of shape, which means that if we are using this filter to convolve this image, then if you try at this location, you should get like very highly activated values. Okay, so the response should be very, very high. Because on the left, it's like patch from the image. And on the right, that's our kernel. Of course, like they look almost similar. That's kind of deliberative. So if you convolve these two, you can see that it's just element-wise multiplication. For all zeros, you will get zeros. And for all ones, it's a perfect match. So you will get 1. And you can just add those values. It will give you 5, which is like a big positive number, which means that the kernel was actually matching with the input image patch. And in a way which says that, okay, we found this match. Now let's try to apply the same kernel at a different location. And it's the same image, but it's just a different location. Okay, so the input image patch will look something like this. And you can, if you try to just binarize this, you will have these values. You can see like that L kind of shape can be represented using these values. Now, if you convolve this with the kernel we had, which was this shape, then you can perform the convolution operation and you can see that it's just going to give you number 1, which is much smaller than 5, which means that you were not able to find the pattern you were looking for in the image. Okay, so then the idea is, of course, using one filter, we can find that pattern. But the interesting aspect is we don't just use like 1 or 2 filters like we were doing in the case of edge detection. We try multiple filters, and each filter is trying to find a pattern, which is actually the pattern it's carrying itself. All right. So if we have like a set of these filters, then we can actually find all those patterns in the input image, and then depending upon that that pattern matching, we can say that, okay, if some set of patterns are present, we can actually use that information for inference for any kind of downstream task, whether it's classification or something. So that's in a way is trying to find features in your input images. Okay, so if you think about this, let's say you have these two different filters. So when you're trying to apply this filter in your input image, that's, let's say if it's going to give you the green activation map, if you try to interpret this, and so this green activation map is actually just telling you at which locations in this input image this pattern was present. Similarly, the orange map here, it's just telling you on which locations in this input image the pattern of the second filter was present. Okay. So let's try to see that using the simple example. And again, this is something we have seen in edge detection. You will have your input image, and you will have different set of kernels. In this case, I'm showing you 2 different kernels. The first kernel is, let's see, the red one, which is like a edge slanting towards left. So if we use that filter to convert to the input image, you can see like you will get the feature map something like this, which is trying to find all the edges which are in this direction. Similarly, the green kernel, you can see that's an edge in the right direction. That's another kernel. Again, that will give you a feature map, which will be highly active in those locations where you have edges which are slantly like leaning towards right. And again, these are just 2 kernels. If you have lot of such kernels, you can find like very interesting patterns in your input image. It can be used for feature extraction.